Okay, so let's start. So is my screen visible to all of you? Can anyone reply, is my screen visible? Okay, yeah, thank you. Okay, so let's start. So yesterday I was given you a slide homework kind of thing that so yesterday we discussed about the sum, the reduction of all the sum in the for using the GPU, right? So I told you that maybe you could try to compute the prefix sum effectively in GPU also. So has anyone tried it? Did anyone get any idea about any hint or anything? But how can we possibly solve this? Anyone? Yesterday also, I mean, yesterday there was some also like also some I given a problem like four kernels. Two kernels will initialize two arrays and then two kernels will update to the two arrays. Has anyone tried that problem? There's no replies. And anyone haven't tried it? Okay, so that would be pretty much simpler. The You can just write the two kernels earlier. I mean, it doesn't matter in which order you write. I mean, to initialize data. So suppose you have two arrays, right? Array one and array two. You can initialize it in any order, right? So you can initialize array one in a and then array two, or you can first initialize array two and then array one. The order should be mettered that after the initialization of the array one, then only you will compute on array one. And then similarly for array 2, after the initialization only you will use the array 2. So you can use the depends on properties, depends on property on the kernel 3 and kernel 4, which will compute the array 1 and array 2. It's so it would be I would also suggest that whoever hasn't tried this approach to try this, and you will definitely see the results. Okay. So, anyone has any other approach which they have gone through or have done something apart from this? Has anyone used any other methods like dot weight and or any other like in order, or might you might have tried using buffer? So you might have seen that the buffer guarantees this data dependency or doesn't it doesn't guarantees the data dependency. You can also look into that aspect. So I mean, yeah, it's for the second lecture, I think. Yeah. So I would suggest you to have a look into that and have a idea about how it is working, and so you can just try out these few examples, how to run it, and you can also test the time for this, and then you can have a look into it. Okay, so let's figure out how to compute the prefixum effectively in the GPU, right? So before moving to this, I would like you, I mean, slight deviation from path. I would just wanted to mention that the types of data dependency which could occur. It's the type of data dependency that could occur in the CPU only. So in the CPU, there could be read after write, write after read, and write after write, right? So it could also happen in GPU also. Sorry, I said only CPU. It could happen in GPU as well as CPU. So suppose two threads are reading, right? So two threads are working in parallel. Now one wants to read and one wants to write. Then there might be clash. What could have happened is, so suppose thread 0 and thread 1, there are two threads which both want to read it, which in which one wants to read and one wants to write, right? So the thread 0 can read any parameter, so it can, so there is no data, I mean, so there is no correct answer, so right, it will not be consistent, right? So so the thread 0 can read the before the updating the value of, so let me clarify it. So suppose thread 1 and thread 2 both are accessing one same variable, right? The array, suppose a data variable, right? And its data's initial value is 0, and then this thread 1 is updating the data value to 5. Now this thread 0 is also reading that in parallel, so it can either read 0 or it can either read 5. So it can read after after the thread 1 has written, or it can read before the so it can read before the thread 1 has written, so then it can get answer 0 as well as 5. Similarly, if both of them want to write, suppose thread 0 wants to write 2 to the data and thread 1 wants to write 4 to the data, then there could be so there is write after write, right? So the data could be 4, data could be 2. You cannot guarantee what will be the data, so that is called the data dependencies. Yeah, so I also given some example. See, suppose like this is thread 0, this is thread 1. Now the thread 0 wants to reads the data of data 1, while the thread 1 writes data 1 equals to 5. Similarly, this could also occur. And now if after write we want, so the at the end, after the execution, after write, the data could be 7 or data could be 5. So it's not so these are the kind of data dependency that could occur. So yeah, so now moving forward to our question, how to compute the prefix sum effectively in the GPUs. So this is the sum, right? So this is the initial array, and this is how the prefix sum would look like. Now I want you to, so now suppose I have just taken this as a variable, right? It's x0, x1, x2, x3, x4, x6, x7, right? Now, now if you closely look, right, this would be the prefix array. So in the first index, it will be the sum. It will be only first element. This is the summation sign, by the way. Whoever doesn't know the summation sign, it means the sum from x0, sum from this variable to this variable. In between all of the variables are summed here. So, so for example, like this is x0 to x1 summation, x0 to x3, x0 to x2 summation, x0 3 x0 to x3 summation, right, and so on. So this is the basically the prefix sum which we will be getting, right? So from this, if you are just considering the elements as a variable, then this would be the prefix sum which we will be getting. Does everyone agree with that? Okay, yeah. So I just tried to also explain in here. So suppose x0 would have somebody here x0, like now what what we can do? Does anyone have any idea? Have you put any thought, right? I mean, how could it be done? I mean, it would be similar to the sum method which we have done in the previous lecture only. Does have anyone have any idea about how it can be done? So let me give you a hint. In the sum, we are able to do the sum by using for loop inside parallel for. Yeah, so how what would be the, so Saurabh, what will be the for loops in initial value and its termination value, and how should we update its variables? So I mean, how should the for loop run? Can you just give an idea about me? So what can you give me the idea of what you are thinking? So I was telling that the basic hint which I was pointing is that it would be similar to the sum which we have done in the previous lecture. So in the previous lecture, you have noticed that the sum we could do in log n time, right? So I'm giving you a small hint that we can do the prefix sum also in the log n time. So if you see that the both are trying to find the sum only, so it is possible to map one thing to another, right? You can also get an idea from this image. So this is also a small image. So suppose if you look here, right? So x2, x1, x0, right? So so in the prefix sum, so let's consider this is one stage, this is first iteration, this is second iteration. So in the first iteration, so we are just x2. So we will just make the summation of x1 and x2 here, x1 and x0 here, and x0 will be as it is. Now, if you look closely, right? So this has the summation of x1 and x2. So this only needs now this only needs x0 to complete as the prefix sum, and this is by default it is completed, right? So in the second position it should be x0, x1. So you can see that after one iteration, so in this first iteration, we are adding the sum of this element and its previous element. While in this iteration, we are adding the current value plus its I mean the some backward elements are not the previous element, previous to previous element, right? So is this giving you any hint? You can just again in similar to the previous lecture, we can just think in the concept of the CPU. So we can just design a for loop earlier, then we can do the thing. So does anyone get any I mean idea about how this could be solved? Anyone? Okay, so let me clarify it a bit more. So let's take a I mean huge example as compared to the previous. So similarly in the previous example, we are just adding in the first iteration, we are just adding the sum of the current value plus its previous element. And then in the next iteration, if you are closely looking, then we are just adding this current sum, current value index plus. So if you are just looking at this index, right? So it should it so we currently have summation 6 to 7, and so we have the summation to 6 to 7. So we need the summation previous to the 6, right? So we will add 4 and 5. So we have just stepped back from. So we are just in the first iteration. We are doing the summation of current value plus one my so the previous element, right? So the current value is if suppose I, then we are just checking I summation I ith value plus I minus one value, right? In the second iteration, if you look closely, then we are summing ith value plus I minus two's value, tooth index value, right? Similarly, so suppose now you can see now we have x4 to x7. So now we need previous or summation of all the previous element before 4. So if you look closely, this is the element, right? So we need. So this is really the element of index I plus I minus 4. So are you getting any pattern? So we are just summing I minus 1, I minus 2, I minus 4th index, right? So does now can you form a loop about how to solve this problem? Now it would be just easy for loop, right? I square, yeah, it is correct. So we will use I square, yeah. So we will first initialize I with 1 and then we will square it. Okay, yeah, definitely. So, but now if you notice this one small one also thing that you should notice here. So in the first iteration, so this is the first iteration, right? In this first iteration, we are on all considering all the elements greater than 1, right? So we are only summing all the elements greater than 1. Greater than or so if you are taking this array as a 0 index, right, then it should be greater than or equal to 1. So this is array index 0 1 2. So the from the 1th index we are only computing the elements, the sum on the indexes which are greater than or equal to 1, right? Similarly, if you look closely, uh, so in the index 0 and index 1, we are not doing any computation. We are only doing computation which has a greater than or equal to 2th index, yeah, correctly. So similarly, this is the 4th, right? So this is also a thing we should do, that you should realize, right? So you should have to might have to add if statement in the for loop, and then you have to come up with some plan or how to solve this, right? So does anyone have any confusion, or does anyone wants me to repeat this, or does it, or do everyone get it? I mean, I will show you the code and make you go. I mean, make go walk you through the code, and then you can understand. Okay. Anyone else have any doubt? Okay, so I mean, we can move ahead. So this is the kind of thing that we have done in the previous lecture, right? So as the Saurabh has told, we can initialize offset with 1. So we will go up till n, and then we can square it. This is basically, so it's not, we shouldn't square it. It should be multiplied by 2. So if you look closely, so it should be 1 4 1 2 4 8 16. So it should be in the power of 2. So it shouldn't be the square. So why it shouldn't be the why it is only in the power 2? Can anyone have any idea about why it is in the, why we are only multiplying it using multiply it by 2 every time? Why are we not squaring it? We have also done divide by 2 in the sum, right? In the previous lecture. Okay, so Prasanna, I mean, do you have any? So you can, if your internet is not stable, what you are saying, right? Uh, so do you have the code or anything that, I mean, you can share? So pseudo code or something. But yeah, I was saying that, does anyone have any idea why we are multiplying it using 2 only? So it's the basic pattern that we can see here, right? So apart from this, this will be the sum. So this how you, when you can just take one big example also, like 16. I wouldn't recommend it because it will be the number of processor usual. I mean, I don't get. I mean, so number of processor. Can you explain it? How the number of processor usual? I mean, if you're talking in the concept of GPU, so the number of processor won't have any. I mean, it will impact if it's the number is very larger. But yeah, we are not talking about that large number. I mean, 1,000 to 10,000, it will be work. It will be completely fine. So the number of processor. So it's not the it's not about the number of processor. It's depends on the pattern, right? Yeah, yeah. So similarly, for the next iteration, we are reducing the initializer by the power of 2. So if you can clearly see that there is a pattern forming, right? So we are summing. So if you are start summing from here, right? So x0 is summed here. then this x0 also reaches here, then this x0 will reach here. And so what happens is, suppose if you look closely to this x0 only, right, then this x0 can be reached, reached here, and then can be reached one step ahead only. So now these two can be traversed into four ways. Now this four will be in so we have to reach this x0 to every index, right? So now we have two x0s. So now we can again reach more two. So this element also got x0, this element also got x0. Now we have four x0s. So you can similarly you can find some pattern. So that if you are if you practice this, you will get that. So this is the pattern that we can solve, and then you can definitely optimize it. So now let's go back to the code. So we will start from offset less than n, offset into equal to 2, q dot parallel 4, and then if so I also said you, right, so in the first iteration we are only taking the indexes which are greater than or equal to 1. Others in the second iteration we are taking greater than or equal to 2. In the third iteration we are taking greater than or equal to 4, because if you clearly see, these all elements will be completely done. So this is the thing that I have implemented. So I have taken the array as one base indexing, that's why it is I greater than offset. If you have considered the array as zero base indexing, it should be I greater than or equal to offset. So now what do you think, is this code correct? Saurabh, what are you suggesting that for the next iteration we are reducing the initializer by the power of 2? Yeah, so I mean also others I would like to suggest that, is this code correct or not? Do you have any idea about this? I mean, so do you see any flaws from the yesterday's lecture? Also, you might find something, or from the today's lecture also. I just wanted to give you hints. So I have just done the slight deviation. Can you see that deviation problem here? Before starting this problem, I have just done a slight deviation kind of thing. Does anyone find any, I mean, issue or any errors or any, I mean, logical thing which we can occur? Is this correct? Okay. Any other opinion? So yeah, I mean, I would like to also think. So suppose, so is there any other comment? Yeah. So the code is not correct, by the way. So yeah, I will get to it why it is not correct. So let's see here, right? So suppose now what happens is, so I have just told you the data dependency guide, right? So read and write concept, and write after read also. So then there is no the data dependency, right? So now what this is doing, it is, so now what this internally will do, it will get this a of I element, then it will get the element at a of I minus offset, and then it will add, and then it will store at a of I, right? So I mean in the back end, right, what it will do. So what could have happened is that, so suppose this is right. So we are looking at this index, right? So we are computing at this. Suppose we are computing this. Now it should read this and it should read this, right? But what happens if this thread has completed its computation of x5 and x6? Then apart from getting x6, we will get the summation of x5 to x6, right? Then there is the data dependency that could have occurred. so we are so apart from reading x6, we will get x5 and x6, and then so here the summation will be x5 to x7, right? So does anyone so there is the, I mean, the problem with the data dependencies that could occur here. So is everyone getting this? So it's the same thing that we have discussed here, right? So someone, so yeah, I mean, it's just a formula, a big formula. So the data one wants to update its 5 and it also wants to read it. So then there is a data dependency issue which will occur, which can occur, right? So this is the thing which is the problem. So what we need to do, so there should be a barrier between each iteration. You all agree, right? So there should be a barrier between each iteration, right? Yeah, but will that solve our data dependency problem that we are facing? The data dependency thing that I have shown you just now. I mean, will the if we keep a barrier sort of thing between each iteration, then will it reduce the data dependency, or will it solve the data dependency that I was talking about? Actually, yeah. And on any other opinion? Yeah, sure. I mean, no, it will not solve the data dependency problem, because the data dependency is occurring in this statement. Suppose the data dependency is occurring in this statement only, right? So in this statement, we are reading one and we are updating one. So we need some sort of barrier before read and after write, right? Then so we will read. So what we can do is we need the barrier between this read and write. So this index will read the x6 and x7, and all these threads will read its the all the values which it needs to sum up, and then it will sum them, right? Then the data dependency will not occur. So am I clear, or does anyone have any doubt what I have said? I mean, so you might think that you didn't get it, so I will explain it in more detail. No, so no. So the in order will do the you are getting this all right. So the in order, what the in order does, it will sequentialize all the kernel launches, right? So if you are written three kernels, and then it will do that the kernel after kernel 1 execution, then only kernel 2 can start. After kernel 2 execution, then only kernel 3 can start. But in the kernel 2, when the kernel 2 is launched, there can be various multiple threads running, right, parallelly. It doesn't ensure the data dependency in order, right? Then it will be just the sequential CPU call. So the what in order does, it's order is sequentialize the kernel executions in the kernel. If a kernel is launched in the device, then there could be multiple threads working, and there the data dependency can occur. So this is the data dependency which we are occurring using that. I mean, so using the in order won't solve this the state data dependency in this one, right? So am I clear, Saurabh? Yeah. So the in order part will not solve the data dependency for this statement. In this statement, we are getting the data dependency because we are reading one element, we are reading two elements, and then we are updating one element. While the two elements, so we are reading this a of I minus offset, right? While at the same time, what could have happened that the some other thread running this same kernel might have update this. So some thread is reading this and some thread is updating this. So then we are getting read after write or write after read data dependency. So we need to somehow create a barrier between this read and write thing, right? Then only it will be, I mean, then only this can be reliable. This can be reliable, right? So does everyone get this, or do you have any doubts? So this is the data dependency which you might occur in the real life also when you are designing some complex algorithms, right? Then this kind of the data dependency you might have to look. So this is the, I mean, so yeah, I mean, I know these concepts are the reduction for some and the prefix sum might be a little challenging, but yeah, you can have, if you have any doubts, you can ask me. So everyone is getting. Okay, so what Saurabh is suggesting is that one thread. Yeah, no. So what Saurabh is suggesting is that we can do is that to have basically something lock kind of thing, right, Saurabh? So what we can do is we can, so suppose if this seventh index wants to update something, right? Then what we can do is, so what Saurabh is suggesting that we can have a lock on both of this element, and then while we have lock, so they cannot update that. So what that is what Saurabh is suggesting, right? So do anyone see any problem in this or any confusion on why it what could have happened here? What could go wrong here? If we are taking this approach, what could have happened is that so suppose let's consider that this element takes a locks on x5 and x6, right? Now this element wants to take a lock on x6 and x7. So but this element cannot get a lock. So this will so this will sum up x5 and x6, and then it will update to x5 and x6. And now this element gets the lock, but the value is not x6. Now it has summed, so the first thread has executed first, so that it has done the summation from x5 to x6, and then again we are facing the same issue that the data dependency is there. So yeah, the lock based technique will not work here. So do you get that, Saurabh? Yeah. So but it's really good that you are thinking in that way. Yeah, we can do this, we can do this, we can do this. Yeah, it will be very beneficial for you in the future. Yeah. So let me help you with this. What we can do, uh, what we can do is just this. Like suppose uh, we will just separate this. So just consider this is a temp I. So this is also a vector of temp I which we are using. So we will separate whole read and then we will write it. So so in the first iteration, what it will do, so this element will read this element, this element will read this element, this element will read this element, this, and so the summation, in the summation we are requiring two elements, right? So it's current value and it's, I mean, I minus offset value. So we are first reading all the elements and storing it somewhere. So this is what it is doing, and then we are updating it, right? So now we have separated this read and write concept. So every element will read the element, and until every element has not read the element, then the execution will not move ahead. After each and every thread has read the element, then only the write will happen. So does anyone have any doubt? So does anyone doesn't understand what this code is doing here and how it is getting implemented? how it is solving this data dependency from read to write. Yeah, we are making a separate copy of an array and performing read on it, and then we will update the element. Yeah. So okay, yeah. So this is the sorry, this shouldn't be temp of I. This should be a of I plus equal to. I don't know why. I will just correct this. This shouldn't be the temp of I. It should be a of I plus equal to. It should be the same, like but plus equal to temp of I. So this statement should be here, but here a part of a of I minus offset, it should be temp of I, right? Because we are we are creating a separate array, we are reading the elements in the second array, and then we are updating it. So it doesn't create the data dependency, right? So we will make a separate copy of this, we will copy that, and then we will again get back to it. So does everyone get this? Or does anyone have any doubt? Before uploading the slides, I will definitely update this. Yeah, we are going to make them into default loop, then by create and fill with first loop. No. In second loop, we are not using temp. This is a typo mistake that I which I have done. So this should be the in the second in the second loop, right? In the second kernel, so in each iteration we are calling two kernels, right? One for read, and from this what should be here is a of I plus equal to temp of I. This shouldn't be here. So this is a mistake which I'm sorry for that, but yeah. So apart from this, there should be a of I plus equal to temp of I. So we are create. So suppose there is a initial array, right? Now we will copy this whole initial array to a temp array, temporary array, and then from this we are updating this. So it's like this only, right? Suppose so now consider we have copied this as a temp array, and now we are updating this in a of I only. So the temp of I is not getting updated. So this will not create so this will not face any issue for write and read and write dependency, right? So is this code correct? What do you think? So apart from this a of I plus equal to temp of I, yeah. Is this code correct? So it is also not correct. It's just that we have to add dot weight here because and also dot weight here because we need to stop after read and write. Otherwise the write and read dependency will occur, right? So if you are not adding dot weight here, then it will not wait, and we also have to add dot weight here also. Then only the read. So read after write there is a barrier, and then write after read also there is a barrier sort of thing. So does everyone get this prefix sum computation? Yeah, it might seem a little bit complex or out of the blood. This is I mean, it's a great problem for you to solve, and I would also suggest you to go ahead and type this code and see if it's working correctly or not, and how it's working, and so yeah, so that would be very beneficial for you. Okay, so is there any doubt for this? Does anyone have any doubt? Okay, so yeah, let's move ahead. So today we are talking, we will study about the work items and no doubt diagram. It will be definitely. Yeah, yeah, I would suggest that. Yeah, any problem which you are facing for the GPUs and all the vectors and for the especially for the vectors kind of thing, right? If you are visualizing it correctly, then it will be surely be helpful. You may find some pattern very interesting that you can use in the GPU, right? So that it would be very help beneficial. So I mean, no one could initially think that, oh, we can do the sum in GPU also, but it's not that efficient. It will not do it in big O of one, but even the log n time, right? It's very very less light as compared to n. So we are getting a great performance over there also. Yeah. So now start with now let's understand what is a work item, right? So you might so yesterday only we have talked, right? Some of you have worked on CUDA and OpenCL and right. So each thread which we are facing, right? Suppose in the CPU also has threads, right? Similarly that every work each time which I was specifying the right. So I'm considering this index will be run by this thread, this element will be run by this thread, this element will be run by this thread. So that terminology, so thread terminology in the Sycl, it is called work item. So work item is basically a single thread in a typical parallel programming model. Single threaded is so that's what, I don't know why it is copy pasted two times, but it's a granular unit of execution, right? It's the smallest unit of execution, right? Each work item will have a unique global and local ID. We will come to this. What is a global ID? What is a local ID? But let's make it so confusing. So it might confuse you now. But with the internet, I okay. So yeah. So work item is basically a single thread running on a system. It's just as simple as that. As a work item, right? Now let's get to the what is a work group. It's a large group of work items. It's a most granular unit of execution, right? Then the work groups executed independently. So yeah, so suppose if we take a collection of work items and combine them, then that is called a work group. We will get into more details of what is a work group and how it is done. So we might have done so work groups execute independently. So let's consider this lesson. Right? So you have a work unit. So work unit work item or thread, right? So I mean a large group of work item will form a work group. Okay, and the device in which you will send the kernel, what they will do is so they will have so your code might have one or more than one work groups, and what the device will do is it will take one work group. I mean, so it will not take one work group, but let's assume it takes some work groups, and then it will complete its evaluation, right? It's or not evaluation completely, but it's execution, right? And then it might switch between them also. It depends on the devices to devices, but work group executes independently. So suppose work group is running parallel, then this work group is running parallel, this work group is running parallel. They are not dependent on it. It might happen that you have submitted more work groups than what the device can take, and then there could also happen that you might be facing some issues, right? So that could also happen. So what could happen that if you are submitting more work groups then the device can run, so it might store it in a queue or something, and then whenever it can take that it will take that work group and it will run it again, it will take, then it will run it. So suppose for let's understand this by an example. Suppose the device can only take 50 work groups, right? And you have submitted 100 work groups. Now what it will do is it will take randomly 50 work groups, and then it will start executing. Now suppose if happens that now it against now the device again gets some 10 work groups, so it can again take 10 work groups free. Then it will again take the 10 work groups which are been left from the remaining one, and in the in the random order only, and then it will start executing them. So that's how the work groups execute very independently. But the work groups, so we don't, if we need to synchronize between each work group, then it will be very difficult. But I mean, so we might get into some concept about the synchronization between work groups yesterday or tomorrow, or maybe some, or if we get the time. Otherwise, the in the if you want to do the synchronization in a work group, it is very cheaper as compared to if you wanted to do the synchronization on the work groups, because as I have told you, these work groups might not be in the devices at a time, right? So as the execution is in totally independent, but the work group which is running on device, yeah, it will we can synchronize that, the all the we can synchronize all the work items which are in a work group, I mean cheaply, as compared to synchronizing between work groups also. So are you getting the, so I will also I will show you the image. Suppose this is the work item, right? Each work item will have its some private memory, some registers and all, and then each work group will have its own local memory. So this combined work item will form a work group, and each work group may have some local memory, and this work group is also connected to global memory, so RAM or something. This then the all work groups are connected to the global memory. So so what happens is each work item has a private memory. Then all the work items combined into work groups. These work groups have the local memory, and all the work groups can also access the global memory. And so the global memory is unique and it is shared between all the work groups, but all the work groups have its own local memory, right? So is everyone getting this, or do you want me to repeat anything? This is clear. Yeah, the work item can also access the local memory, yeah, of its work group. Work item, so what happens is this work item is only accessing the memory. This is the hierarchy, right? So in the CPU we have seen that the CPU is there, then registers, then L1 cache, L2 cache, L3 cache, RAM, and then hard disk, right? So this is the hierarchy. So for CPU, accessing from the register would be the easiest task. Then what it can do, then as we go up in the hierarchy, the latency will increase for the memory. So for the work item, it's getting the data from its private memory is faster, right? Because there are the registers. Then if you are getting the memory, getting the data from the local memory, it's slightly costlier, but it is cheaper than global memory. But now if you want to access from the global memory, then that is costlier as compared to the local memory and the private memory. So this is basically hierarchy of the memories. Okay. So do you get what the I mean? So there are the various optimizations and various things which can be done in the work groups and all. I mean, if we get the time, we will discuss them, and yeah, surely that. Okay. So does anyone have any doubt about this work groups, work item? Again, I want to clarify, work item is the smallest unit in which will execute this. So suppose in this code you are writing this I, right? So ID, this N. So there will be N work items that will be launching, and the N work items will be running on parallel. So each work item will have its own ID, right? And that is called the global ID. So we will come back to that global ID and that. But then the work items combinedly form work groups. In each work group can have its local memory. Yeah, that's what it is. Each work item is just a thread. Yeah, it's a terminology for the Sycl that work item is just a thread. Correct. Yeah. So everyone got it. So do anyone wants me to repeat this? Okay. So let's move ahead. So now what is a global ID and local ID? Let's clarify it. So what we are doing is that we are using this n. I'm just directly taking this I, right? So this is the ID in the range one, and then we are just using this I every time. We are just assuming that. So suppose this n is from n is 10, right? So we'll just assume that so there will be nine. So there will be 10 threads indexing from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is the thing. Now this whole, so that ID is called global ID, right? So each element will have its own global ID. And now what happens? Suppose let's take this diagram only, right? So so there are eight work items. We are launching eight work items, and we are forming two work groups. Okay. So what is there now? What is the other? So this work. So suppose the global ID of the each work item is so let's assume this is 0, 1, 2, 3, 4, 5, 6, 7, right? Now for this work group, so the local ID is for this work group, right? So for this work group, the local IDs could be 0, 1, 2, 3. And for this work group, for this work item, the local ID might be 0, 1, 2, 3. So a work group can have n work items, right? So from 0 to n minus 1, they will be getting so each work item will be getting one unique local ID. So does everyone get this? Or what is the global ID and what is local ID? Yeah. Okay. Great. So we can directly use this. Okay, so this is it's not okay. So we can directly use this get local ID get global ID use. So so suppose so now local. Now let's also discuss about n range, right? For so if you are looking the previous code, we are just using this range, right? So this is so if we are using just the range, then this is the one dimension range, right? So this is the range one. So we can also write two dimensional here also, but this is the basically the range is of one dimension, right? So it will be something like matrix or vector kind of thing. So it will just initialize from 0 to n minus 1. Now now what we are doing is we are doing this n range. So why do we need this n range, right? So suppose if you want to create a subgroup, and so what basically happens in the Sycl is that the subgroup and the sum items will so work groups and the work items will be created by itself. So it's defaultly it will take the some optimization for it, and then it will do that kind of thing. It will assign some work items to this work group by based on this device configurations and also so that's how it does it. But now what we to get the benefit of these local memories and the private memories, we might want to create work groups from our own, right? So if I know that this all work items may need the some data, and this all work item may need some data, then I would like to create this work group and get all that work items in this work group, right? So for this, we have to change this range to ND range, so that it will allow us to create the subgroups and work items the way which we want, right? Apart from the Sycl device configuration to do it, right? So this so ND range is used there. So we just want one dimensional, right? Then what this is that, so there are total 32. So what this 32 means is we need total 32 in total 32 work items. And what this indicates that in each work group we need 16 work items. So let me again say is what the Sycl basically do is it creates the work groups on this system, on the device configuration, and compiler might think of, yeah. But if you want to take the control, if you want to get some optimizations, if you want to use some local memory of the kernels and all, so we might have to create our own subgroups, and then we can optimize it. So for that we have to change from the range ND range, and then we have to give the dimension of, and what dimension we want to get the data. We want the data. We want the, sorry, indexing, right? Then we have to tell the total how many work items we need to launch, and for each work group how many work items are there, right? So similarly, if we want, if we are, so we are just writing item, right? So if we are using ND underscore range, then we have to use ND underscore item. So this will give, yeah, one by one each item. So am I clear? So this example will create 32 groups, and each work group will contain 16. No. This will create 32 work items. So it will create two work groups, and each work group will have 16. So first index is that how many work items you require. So this tells that we require 32 work items, and each work group will contain 16 items. See, so the total not subgroup, it should be work groups. The total work group will be 2. No. So you are just, so let apart from using work item, I will use the thread here. So what it tells is I will launch. So I need 32 threads, and each group will have 16 thread. Okay. So I need 32 threads, and each group will have 16 threads. Now do you get it? So there will be only two work groups. So there are 32. So I want 32 apples, and in each box I need 16 apples. Okay, yeah, I will. Okay, so let's take an example, right? Okay, yeah. Let's take so I don't know. I will just take an example, and then I will explain you using thread also. Suppose I need 30. So I suppose I tell you I need 32 apples, and I want, obviously I want them in the box. So I need, so what this 16 indicate that in one box I need 16 apples. So how many box you will give me? Suppose I tell you to give me 32 apples, and in each box I need 16 apples. So how many box you will give me? Yeah, 32 divided by 16. So two box, right? Now similarly 32 apple, apple means thread. and box means work group. So now do you understand how it's now how it is used? Okay. Yeah, got it. So yeah, so it's just a basic code where you can try this out and see what it will give the output. So until this, does anyone have any doubts or any confusion? Does anyone have any doubt? Yeah, so this example will create two groups, two work groups. Yeah, it's just similar to the apples. You can remember this example, right? So I need 32 apples, and in each box I need 16 apples. So there are two boxes. So there are two work groups. I need 32 threads, and in each group I need 16 threads. So there will be two groups. Yeah. So does anyone have any doubt? Okay, so we will take from 5 minutes, 5 minute break, and then we can again start from here. So until this, if someone has any doubt, they can just chat, message me. Okay, so is everyone back? So can we start? Can others just confirm that we start? Just let's wait just one more minute to others for others to. Okay, so let's start. So now for currently we have taken example of range 1, right? With range, I mean dimension 1. It's one dimension, right? So this is the one. So it means it's only one dimension. Now let's take an example of two dimension. So we can also create, so let's also clarify, this is the global range and this is the local range. This is what we are saying, right? So global range means 32 means global range means we need 32 apples, and so 16 local. So in each box I need 16 apples. So this is the global range and this is local range. So just like we are talking here, right? So suppose in the global we need 8 work items, and while in the local there are 4. So its range is 4 and the global range is 8, right? So this can also be called as global range and this is local range, right? So now what we can use is define the global 2D range. Now we are just updating 2D ranges. Now we're just taking an example of 2D range, and this is for you to try out what should be the answer, what will be the result. Yeah, so suppose if I take, I can also assign a global range like this. This is the syntax Sycl, scope operation, then range, and two means two dimension. And then we will assign that I need 4 x in 4 range in x dimension. So suppose if we are taking a 2D, then let's take x direction and y direction, and then I need 4 elements in x direction and 4 elements in y direction. Therefore total I need 16 in global range, and in the local range I need 2 into 2, so I need 4, right? So then we can directly use so we can also create this ND range using the global range and local range, and then we can just pass this ND range here. See, so then we'll also use ND items too. So what do you think? What will be the work groups? So how many work groups will be created here? So if this is if we are using two dimension, and then we are using, so we are having four, so in the global range is 4 cross 4, and then the local range is 2 cross 2, then what should be this? So I mean, I think Saurabh is trying to say 16 divided by 4 equals to 4, right? Yeah, absolutely. So there will be 4 work groups. So it's just like similar, like I need 16 apples and in each there are 4, so I need 4 boxes, right? And then we can just get the, so okay, yeah, to get, so now we have indexing, right? So I need the global index in x position and y position. So I need to use this item dot get global id. 0 means in the zeroth dimension, in one dimension, in two dimension. So it can be it get so I think the Sycl, I am not sure, but the Sycl is only allowed to use, I mean in the Sycl we can use this up to 3 dimension. So we can get global z direction also at that item dot get global id 2, and then we can also get its local id, and then you can try its various examples, you can try various practice, so then you can also use this sort of thing. You can also get the store the data in the this data buffer, and then you can print it, so you can get to know, okay, so so this many local indexes are calling and this many global indexes are being called. Okay, so it would be a great practice for you. I would suggest you to do this. Okay, so okay, so let's move on to SIMD. What is SIMD? Does anyone know what is SIMD? I mean, the folks who had studied slight of CUDA and all might know what is SIMD, right? Yeah, single instruction working on multiple data. Does anyone? Yeah, so this that's correct. Prasanna is right. Single instruction, multiple data format. So what does it means? So it means that a group of work item. So a single instructions means so group of threads are working on same instruction, but with each one has its own data, right? So in a broad way it is like this. So it should be like this round kind of thing. So what I mean, all of them might have a different data, but they all be will be working on same instructions. Yeah, this is a hilarious example, but yeah, but consider the iteration. So if you're going in the basics of COA, right? So it will be it will be in the current instruction. So the Ravan will be at particular point at the same some steps, and then but each and every head of the Ravan uh, can uh, can have multiple data, can say differently, can say different things. In each head of the Ravan can think different things, right? So it will be the same thing. So while executing the code, if the code has some instructions like so S1, S2, S3, S4. So now all the threads which are working in CMD, single instruction, multiple data. So all the threads will be reading the same instruction, will be performing the same operation based on the instruction which is given, but they will be performing the instruction on their own data. So it will be great beneficial. So it will be, I mean, so this is the concept that is used by the GPUs and all to increase their performance. So so we don't need to read the data that much. So suppose the data is in the register only, then we can directly just do the computation on then, and so the latency reduces, right? So does everyone get this? What is SIMD? Does anyone have any doubt what in the single instruction multiple data formats? I will again want to clarify that. Suppose there are four instructions. Okay, so it will be faster, right? Assume that there are. So let's consider 16 threads are running, right? And 16 threads 16 thread will read the same instruction. So for each of the thread might call that so each thread have to fetch the instruction from the memory and then perform the computation on the data. So there is a memory call, right? So we need to fetch the instruction. So while in the CMD there is only one fetching occurring for 16 threads. So do you get that? So how it's making the GPU faster? So there are 16 threads and each of them are fetching the instruction. While if we are using the SIMD operations, then only one time the instruction is fetched and then the computation is performed on all the 16 parallelly. So do you get it right now? Now, do anyone has any doubt? Does anyone have any some doubts or so? Then they can speak up. I mean, guys, you can also unmute your mic and say me that I didn't understand it. I need to have some clarify idea about that. No, no means did you get it? Okay, yeah. So, so we have studied about work items, work groups, right? The threads and the threads and the work groups means box, Apple box, right? Now we are going. So let's think that so I've just given an example of 16 threads working in SMD. So in the Sycl, those 16 threads will be considered in a subgroup, right? So it will be considered in a if it is it will be in a subgroup. work item, work group, subgroup. Subgroups is different from work group. So if suppose in a group, suppose in a box there are 16 apples, and the 8 apples are performing the task in SIMD, and other 8 apples are performing the task in so this 8 will have its own SIMD, and this 8 will have its own SIMD execution. Both of them will have its own SIMD execution, 8 8. So there will be two subgroups inside a group, total group. So suppose if a box has 16 apples, and 8 apples are being eaten at same instruction, and the other 8 are being eaten at same instruction, then the whole box has two subgroups, and in each subgroup there are 8 work items, and the whole box will have 16 work items, right? So are you able to visualize this concept, right? So this imagination that how subgroup will be formed and how it will be done. So a group of work items is a subgroup. The execution in the lock, so it execute in a lockstep manner, right? So after every thread completes the execution of one instruction, then only it can move to the next iteration, next instruction, right? Until that point, every each and every it's a lockstep, right? So suppose 16 threads are working on in SIMD, and then if they are performing a operation on the on some instruction S1, and then there is S2, none of the thread can be able to move into in the for executing the S2 instruction until the instruction 1 has not been completed by 16. Computation on the instruction has not been completed by all the 16 threads. So executed in the lockstep on the SIMD hardware. Okay. So there is an implicit barrier after each step. So each instruction, so think like this. So suppose there is a barrier kind of thing after each step for the SIMD, for that subgroup which has been formed, and which will be working on a SIMD instruction, which will be worked on SIMD hardware. Okay, so work item within a subgroup can synchronize and communicate without any latency. Yeah, so they can also, the work item within a subgroup can synchronize and communicate without any latency. It is also an optimization task. So the subgroups can do this, then do this. So suppose, yeah. So similarly, if the read write, which we have been through that in the prefix sum, right? Suppose there are suppose a subgroup contains 16 thread, and there we need to find the prefix sum of just 16. Then they will, so we not don't need to separate them into the two kernels for read and write. By default it will be the separate, right? Because each instruction will first fetch the read, and then it will write. So there will be so we don't need to synchronize them. uh, does this make sense? Does anyone have any doubt why it will be like this, why it is facing here? Okay, yeah. So the, yeah, similarly the thing which we have, which the example which I've given, the work group can contain multiple subgroups. The example which I have given, like 16 8 8, so work group has containing two subgroups, right? So it can contain multiple subgroups. So yeah, these are the some various, these are the some parameters, and other parameters I would like you to go ahead and search, and because it's not possible to complete the whole cycle in just 2 hours lecture. So I would suggest you to go some and try what it is giving, what is the global range it is giving, local range giving, group range giving. Okay. So yeah, also I wanted to just add a few points, is that the subgroup and the Sycl, the size of the subgroup depends on the device configurations, right? So it can be 8 16 32. It will be mostly in the multiples of 2. So 8 16 32, anyone, it's mostly in 16 or 32. But and then Also, but you can also change the subgroup size. So there are functions available. I would like you to suggest. I would suggest you to just search that and resolve that out. What if we change this subgroup size? Then what will happen? I would like you to think in that direction. That okay, I need. So these 30 data elements are almost working in the SIMD operation. So for optimizing that, and if we are using synchronization method, then okay, we will, if we are creating 30 element subgroup, then we will be working more effectively. And what are the side effects of changing the size of subgroups? I would like you to go ahead and think in that perspective also. Okay, so yeah. So okay, and one more. So this is a kernel. So let's go to the example and let's get into more details. Okay, yeah. I would also, so yesterday I was, so yesterday someone has written that printf, I think, right? So so yesterday only we have discussed in that perspective that we cannot do the printf inside a kernel in the Sycl, right? So we need to overload the out operator. So we have just created a stream. I would like you to go ahead and just search what this parameter do, what these parameters do, what this parameter do. See guys, I'm giving you some idea. I will give you the basic concept. I will learn you these basic things, and then I would like you to make one step ahead. Make one step ahead. If there is any doubt, you can just post it, or you can just okay, contact me also. So I've just so this is also it's not only dependent. Okay, so yeah, we need to also pass the handler for this stream, and then I've created a ND range of n and b. Suppose n and b is, I don't know, you can take whatever. Suppose n is 64, b is 32, and then we have used this ND item. Now if you want to get the subgroup, so we have to first get its so this what this does is item dot get subgroup. So this will get a subgroup interface sort of thing, class object something sort of. From that sg dot, from this sg dot, you can get its group id, its group range. So group range is this is the group, subgroup is of 32 size, 16 size, then its local range and so on. So I would like you to, so this is the result which I had got using this concept. Okay. So I would like you to try, I would like you to understand what this is doing, what this is doing, what this is doing. Also try, also I would suggest you to manipulate this thing. I mean, I would like you to say, yeah, so create an array, multiplication, subtraction, yeah. To do some computation based on this subgroup, how the CMD is performing, what if I am doing this. You can also use the prefix sum kind of thing. And as I told you that, so if the prefix sum, we have separated the read and write, and if your subgroup is, so my subgroup size is 16, right? So if your subgroup size is also 16, then what are you getting? Then the prefix sum, the read write data dependency is occurring or not occurring. So these are the some sort of things which you should be asking, and you should, I would suggest you to do some, I mean, testing in that as perspective as well, so that it gives the clarifies to it, gives the basic idea to you. Okay. So does anyone have any doubt about basic idea about what a subgroup does? No doubt. Does anyone have any doubt? Okay. So let's move ahead. But what? Okay, now it comes the interesting problem. So what I have told you that SIMD will not start executing its next instruction until that all the threads have completed that instruction. What if there is an is if else condition, then what do you think will happen? Suppose there is an if, then there is an if block, then else, then there is the else block. And suppose half of the, so there in a subgroup, if there are 16 threads, and if the 8 threads are going in if block, and the remaining 8 threads want to go in the else block, what do you think will happen? Again, I want to clarify. So suppose, so we have gone through that the SIMD instruction occur doesn't, so it will not start executing its next instruction until all the threads have completed the instruction. Yeah, the person nice, right? So what happens if there is an if block, and so if statement, and there is if block, and then there is else statement, and then there is else block. Now what will happen in this concept? So what do you mean by half threads will produce different output and half will produce different? So I'm yeah, the output will be different. I want to know that how the execution will happen. So it is just like this, eh? So suppose I told you that so there is a if statement, right? So this is the S1, right? All the 16 thread will be executing this S1 statement. Then there is an if block. Then there is S2 block, S2 statement, right? Then else S3, then S4. Now all 16 thread will execute S1 and then it will move to if. Now 8 threads want to go S2 and other will go to, or other wants to go to S else statement, right? Now there are only 8 threads which should execute S2 instruction, right? But there are 16 threads, and I told you that until this instruction is not completed by all the threads, it cannot move to other step, right? So what will happen? So 16 thread will be here, then it will be here, then now only 8 threads can run S2. Other threads will not run this. So now what do you think will happen? Any ideas? Right. So there are no warps concepts in, so warp is basically what a warp is, the subgroup which we are talking about in Sycl. Okay. Yeah, so no, what will happen is, so that's it's simple. It was a tricky question. It wasn't that easy. It wasn't that hard. So what 16 thread will execute S1, and after each and every thread will execute, then only it can move ahead, right? So now if statement all 16 thread will execute, now they will know that S2 has to be executed by 8 threads. So 8 threads will execute S2 while other 8 threads will be stopped at S2 only. They will perform no operation, NOP, no operation will be performed by them. And then the else statement, and then the 8 threads which have performed S2 will perform no operation, and the other 8 threads will perform 8 S3, right? So are you saying that the thing, right? So suppose by using the SIMD format, SIMD hardware, what is happening is that the if statement, the threads should complete, so either so I so let's think in the perspective of one thread only. So suppose we are not consuming the SIMD, considering the SIMD format also. Suppose there is only one thread and it wants to execute, so it will combinedly execute S1, S2 or S3 and then S4. So it will only needs to execute only three operations, three instructions, right? But now here, because of the SIMD, so the threads needs to some threads needs to wait for some other threads to complete their execution and so on. So instead of using instead of waiting for instructions, it has to wait for four instructions, right? So there is some delay for this. So are you getting this? What is the problem that we are facing today? What is the problem that we are facing using by because we are using this SIMD hardware? Can anyone confirm that? Are you getting, or should I just repeat once again? I'll just explain you with a diagram also. Suppose there are only eight threads, right? So S1, okay, so I just so it should be S0, S1, S2, S3. Just consider it this way. Suppose the S0 instruction will be done by each and every one, right? Now this four instruction wants to perform S1. Now this other four will be will be else statement, right? So this all four will will execute. So while that time this all the odd indexes thread will perform no operation. Will perform no operation. It will be just in a hold wait state, right? And then the S3 will execute. So if we are using a single thread, if we are not using the SIMD hardware, then what could have happened is this process could have completed in 3 cycles, but now we will require 4 memory cycles, right? So are you seeing the problem that we are facing? Yeah, Saurabh, it's correct. It's similar to the thing that I have also shown you in the diagram. So the eight, so in this diagram there are only eight A0, yes. So then it will then the four will execute, then four will be in wait, then other four will execute, and then four will be in wait, and then S3 will happen. But do you see the problem? What it is occurring? It is requiring one more cycle. So it's requiring for one cycle it needs to wait. So are you seeing this problem, right? Okay. So yeah. So now, so this is the problem which could have happened, but the Sycl uses the AMD hardware, so we cannot do anything about that. But this is the problem that we can face this. Okay. So so you should be aware about. So if else statement you should be aware about. Uh, okay. When so just when different work items execute different instructions, work items. So this is called uh, thread divergence, right? In this view, that so it is basically work item diverging the work items, right? Some of the threads are diverging and some of the threads are waiting. So this is called a thread divergence. Okay, when different work items execute different instructions. See like here. So some work items want to use this instruction and some work items want to use this instruction. Then the work items are said to be diverge. Okay, hardware executes work items satisfying some conditions together, ensuring that the other thread executes a no operation. So this is no means no operations. So what this happens is this adds sequentiality to the execution. Let's consider. So what do you mean by let's add this add sequentiality to the execution? Let's assume that there are, so for this example, let's assume there are eight if else ladder, right? So there are eight conditions, and each thread wants to perform only so each thread will just so there is each thread will just satisfy one condition in eight also if else ladder, right? Now this will add a sequentiality to code. We doesn't so what ideally should have been done, it should have been completed in 3 cycles, but now it could have taken, so it will take, so each instruction, so each thread wants to perform a separate instruction. So now it will, for each other thread will wait for that, so there will be 8 plus 2 10. So apart from completing into 3 cycles, it will take 10 cycles, right? So are you getting this problem? So it can add sequentiality to the code, and while writing the code, you need to be aware about this. So, okay, so this can increase the latency of my code, and so this is how I need to figure out how to optimize this. How can I reduce this if conditions and all, and how, okay, and how to, I mean, basically optimize my code. So are you getting this? Is anyone having any doubt? Okay, so I would like you to go ahead with this and say and tell me that will this code face the thread divergence or not? I would just so will this code face the thread divergence or not? No. Why do you think no, Saurabh? You can just unmute and say also, it's fine. Does anyone have any other opinions? So this will face the thread divergence. How it will face the thread divergence? Suppose the n is 16, right? And let's consider the work groups to be 8 or 16. Then all the odd I index. So how the work group will be in the sequential order, right? So if the global index is from 0 to 100, and so the work groups will be, so suppose it is 8, so 0 to 7, then 8 to 15, 8 to 15, and so on. The work groups will be in a, so the all the indexes in the work groups will be in a contiguous manner, right? So the work groups are formed basically in that structure. So all the event index wants to write the data to 0, while the odd index wants to write its update to 1. So there is clearly thread divergence. It's the same thread divergence that I have shown here. So it will face the thread divergence. All the odd threads want to update it to 1, or all the even threads want to update it to 0. Sorry, vice versa. Or the odd wants to update it to 0, because different threads may take different paths. Yeah. So this is it. Suppose there are only 8 threads. Let's consider 8 threads, right? So now from that 8 threads, four wants to mm, take the four wants to make the data as 0, as their data, as their value as 0, while the other wants to make their data as 1. So they both want to take the different paths. As they both want to take the different paths, while so let's come. So the odd wants to make, so it will check. So what happens? All the 8 threads will be here. It will check this condition, and now the 8, for the 8, the flag will be true, right? So now the 8 instructions want to complete this instruction. So at that point, so not the eight, the four threads wants to complete this instruction, because there are total eight threads, so it will be numbered from 0 to 7. So there will be four odd number, four even number, right? So four threads want to complete this instruction, and as we are performing in the SIMD instruction, the other four instruction have to wait there. They cannot do any other operation apart from this. They have to wait there. Now they will go to this statement, and the four that we are waiting in this step will execute, and the other four will wait. So this is the way that the thread divergence is created. Did you get that, Prasanna? Okay. So does this code diverge further, and assume that the data is initialized to 0, 1, 2, 3. So I'm consider this code and consider this code. So this code has some thread divergence, right? So will this writing this if else statement extra, will this make that the code will diverge further? How do you think that sort of will it make the code to diverge further? Okay, so we have different answer. One thinks that the divergence will increase, and one thinks that the divergence will decrease. Okay, so let's consider using the example only eight threads only, right? So eight threads will come here. Now what will happen? All the odd threads wants to execute this, right? They will not, that doesn't matter about this if else statement and anything, right? And all the even, now all the even threads are only remaining. They will only check the if else statement, right? So now this even thread will check this else if data I modulo 2. So all the even threads are only remaining, right? And all the even threads will definitely be modulo by 2, because the data is initialized in that way. So they will, so the whole execution will be completed by this. So none of the instructions wants to execute this else instruction, right? Sorry. So this is data ID modulo 2. So all the data value at index e1, so which are at index e1. So this is at index, this is 0, 2, 4, and so on. Will have its modulo 2. S- So it will be, so it will not, so any threads doesn't wants to execute this data equal to, it doesn't wants it data to become 2. Other four also wants to make this data of id equals to 1 only. So there will be no change in the thread divergence. I will again explain you. So what happens if when it comes to the if statement, all the odd threads wants to execute, they wants to make their data to 0. Now now it will check the if else condition. None of the remaining four thread will satisfy this condition, and then it will make the else. So other four threads will execute this, will make its data equal to 1. So there will be no divergence of the thread more. So there is just one divergence of 4 make, and so it will not further diverge the thread. Do you get it? Does anyone have any doubt, or do you want me to repeat it? So no, this code will not. Yeah, it will directly diverge. So it will not go into execution of this state. So if four do this, two do this, four threads perform this instruction, two thread perform this instruction, two thread perform this instruction, then there will be then the divergence will increase. But here four will do this, four will do this same way in the previous, so there will be no further code divergence, right? Okay, now come to this. What do you think? This will this make the so suppose yeah, okay. So suppose what I have done, I have launched more number of threads than the vector which was available to me, and then I don't know why I am doing that, but I want to launch more number of threads compared to the vector size. Vector is means array size. So I will just checking the condition. If array size is less than n, then I will perform some instruction, or otherwise I will perform some instruction. So will this have any thread divergence? We will come back to this problem afterwards. First, we will just solve this problem. So let me help you with this. Suppose n is suppose, yeah, it will depend on the n and vector size. So you are definitely correct. But I want you to have a look into this. Suppose there are various subgroups. So suppose there are 15 subgroups are working in parallel, right? And from that 15 subgroup, there will be only one subgroup which will have a thread divergence. All 14 will work completely fine, because either they will be less than n or they will be greater than n. It is only possible to have a one subgroup in which this thread divergence is possible. Are you able to see this? Suppose I would want you to try out this example with some pen and paper. You can just visualize that. Okay, so suppose take n 15, threads as 8, and vector size as 30, and you can just verify it that there will be only one subgroup which will face the thread divergence. Other all subgroups will be working perfectly fine. Okay. So now I also want you to have a look into this. If the subgroup size is 16 and I am using this, will this have the thread divergence, or will it not have the thread divergence? It will diverge. Any other opinions? So yeah, let's take an example. Okay. So this is the global ID. Okay. So 0 to 30, 0 to 31. Okay. So there will be two subgroups, 0 to 15 and 15 to 31, 16 to 31. So 0 for all this subgroup, 0 to 50, this will give the 0. So they will start executing this S2. So for this subgroup, 0 to 15, there will be no thread divergence. Now for this subgroup, 15 to 31, this condition will return 1. 16 to 31, sorry. So all the threads will start executing this S1 block. So they will none of the threads want to execute this S2 block. So there will be no thread divergence in this case also. So Saurabh, did you get it? Why there will be no thread divergence? Or does anyone have any doubt? No, 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 no. Yeah, yeah. For the first subgroup is from 0 to 15, right? So if condition will be false for that, so all the threads from the subgroup 1 wants to execute this else part, while all the threads from greater than 16, so the second group will have the id from 16 to 31. So they wants to execute this. So for that, if statement is correct, so they wants to execute, all the threads wants to execute this s1 statement. So there will be no thread divergence, none of the thread is waiting, so there will be no thread divergence. Do you get it? Okay. So what we see, that the condition, so there is a conditions, but there is no divergence, right? And also the different truth values but no divergence. So so for each work group there are different truth values, and also but there is no divergence. So it is not necessary that the conditions are bad. Evaluating to different truth values for each subgroup is also not bad. So for this the correct, so for this the condition is not bad. For this, that each and every subgroup will, each and every thread will, so for this, suppose we have taken an example like the 15 subgroups, and in only one subgroup will have the thread divergence, right? So that one subgroup, even in that one subgroup, each thread might have different values, but it is very negligible divergence, right? So it's okay, we can neglect that one divergence. So what are the takeaways? That the conditions are not bad. Evaluating the different truth value is also not bad. They evaluating to different truth values for, I mean, so I've just used verb. It shouldn't be verb. It should be the subgroup thread is bad. So for if the in if in a subgroup, if the threads are evaluating to different statements, then only it is bad. But if you are creating some if else statement in which the conditions are such that all the subgroups thread wants to execute same instructions, then there will be no thread divergence. Do you get it? Does everyone get it? Statements to execute before or after conditions are bad. Sorry, I didn't get what you are saying. Can you explain? Can you explain me in detail what you are trying to say? Yeah, in this example. So no, no. S1 executing S1 is right. Is it doesn't create any divergence, because if it is not in if else block, then every threads will definitely want to execute that instruction, right? So we have to only take a look in the for loop, while loops, in even if we have used some if else statement also, then only it will be the case that some threads might want to execute this instruction, while some other threads might not want to execute this instruction. Then only it will create the problem. Okay. So you got it right. So I would like you to some try up with examples, and I know that today is I mean today there is lot to grasp up, but I hope you got some learning from it, and thank you for it. Then we will meet shortly. Yeah. Okay. So bye. I'm ending this session. Does anyone have any doubt? Exercise, that would be exercise for what do you want, Prasanna? For which part do you want?
I mean, I want to try out all the divergence and see how in when I mean when what is the actual weight when threads diverge, and then
Yeah, so for that, what you can do is similarly the thing that we have talked, like so there is one function from that. First get that the device which you have assigned, what is the subgroup size, right?
yeah,
So you will get the subgroup size, and suppose if you create some kind of condition, right, that all the 16 wants to, so suppose in my example, so see if you see that for me the subgroup was given 16, right, subgroup size. So if you create that each in the subgroup each work items want to execute a different instruction, then you can measure the time that all the 16 wants to execute different or same instruction, and all the 16 want to execute different instruction. Then what is the time? Then you can measure it. Then you can see that okay, yeah, so this is how the thread divergence is affecting me.
got it. Okay,
Okay, so that could be the example that you can do. Yeah,
okay, thank you.
thank you.